In our next example, we have negative 2x plus 8 bigger or equal to 0. And we are going to solve for x the same way as we did before. So I want to isolate x on the left-hand side. So I move the 8 over the inequality, and that becomes negative 8 on the right-hand side. Now I want to find x alone, and I'll divide both sides by negative 2. So on the left, if I divide by negative 2, I will have x, and on the right, I'll have positive 4. But notice that the direction of the inequality changes when we divide by a negative. But actually what is happening is we have negative 2x bigger or equal to negative 8. And if I move the negative 2 to the right hand side, I will have 0 is bigger or equal to negative 8 plus 2x. And if I move the 8 back, I have 8 is bigger or equal to 2x. And now if I divide both sides by 2, I have 4 is bigger than x. So it's important to know that an inequality can be read from any direction. So in my notes on the right, if I read from 4, I can see that 4 would be bigger or equal to x. But if I read from the position of x, I can see that x would be smaller or equal to 4. And that is what happens when we divide by a negative value in order to solve for x. So remember that the direction of the inequality would change. So again, I have a number line that are both positive and negative. And I locate 4 on the number line. And I indicate 4 with a closed O because x can also be equal to 4. And we consider x to be any value that is smaller or equal to 4, all the way to negative infinity. So that includes 4, 3.5, 0, or any value towards the left side of 4. And my interval notation, I have negative infinity as my minimum value, and my maximum value would be 4. But now I use a square bracket to show that x can be smaller than 4, but also equal to 4.